So next up with 9-4, we get to talk about ellipses. Ellipses are going to be kind of that oval shape that we see, and they can be either oblong sideways or oblong vertically, or horizontally and vertically is what I should be saying. So there's going to be four main vocabulary words that I need you to know for this. The first one is going to be the center, and that should be fairly familiar. Just like a circle, there's going to be a center of it. And then the next one is going to be the vertex. The vertex is going to be the point where the ellipse turns around on the long ends. Okay, so on a horizontal one, it's these two. On a vertical one, it's this one right here and this one right there. The um, the sideways ones are called the covertices or the covertex there. Now the distance between the two vertices is going to be called the major axis. That's going to be important here in a minute. The major axis, the minor axis is going to be the short distance. Now I don't like the way the book has these two tables set up. We're going to have to kind of look at two different tables to get all the information we need. First of all, we can tell if it's going to be horizontal or vertical based on if X is listed first or if Y is listed first. And you'll notice then that the length of the major axis is going to be 2a. A is the distance from the center to the vertex. So the bigger number is what's going to be in the first fraction. So that makes a difference on your A and B there. Or I'm sorry, on your X and Y there. And then notice that the length of the minor axis is 2b, where b is the distance from the center to the covertex. So this little blue segment is b. This long segment, not the green, but all the way from the center to vertex, is going to be a. It's also known as c if it just goes to the foci, and then there can be a, but that's going to be more in depth than what we're going to do right now. So this is the second table, and if we were in class, we would talk more about this stuff, but we're gonna do a more basic view at ellipses today. This right here, though, is what I want you to notice is H and K. The center of the circle is still at HK. H is still paired with X, K is still paired with Y in both instances. So let's do an actual example real quick. So this over here is an ellipse, and I have the center marked for us. You can assume for today that all ellipses are either going to be straight horizontal or straight vertical. And so here's a vertex. Let me see if that'll circle for me. Here's a vertex. Here's the other vertex. Co-vertex and co-vertex. Most of the time you'll be able to look at it and visually tell whether it's a horizontal or vertical ellipse. But if you can't count the major axis and the minor axis, it looks like this horizontal one is 1, 2, 3, 4. And the vertical is 1, 2, 3. So since the longer measurement is horizontal, that definitely means this is a horizontal one. So I'll be wanting to use this equation over here, which means I need to start with parentheses, x minus, now what is my h value? Well, we're going to need to find the center of this. So the center is at negative 1, 2, 3, negative 3, and then it goes down 1, 2, 3, 4, 5, negative 5. And if my centers are always at HK, then it's a negative 3, which is going to be a double negative. So that just makes it a plus 3, and you do square that. Now, this is a lot like circles so far, but the difference is you're going to divide by the major axis squared. Well, the major axis is the longer one, and it's just from the center to the vertex. And since it's 4, 4 squared is 16. Then I'm going to add y minus, oops, there we go, k. Oh, my k value is negative 5, so that's going to be a double negative. Don't forget to square that. Oops. That's supposed to be a squared. Let me try that again, sorry. There we go. And it's over the minor axis, half of the minor axis squared. So from the center to the covertex, we've already figured out that that's 3. So 3 squared is 9. And then it is always going to equal 1. So to see that a little more neatly, let me pull this up over here. That is the equation right there. And it is supposed to equal 1. Let me pull up another example super duper fast. Okay, I have a second one lined up, and this one is obviously a vertical one. So I'm going to start by going ahead and writing my parentheses, y minus, and get ready for my k value. So my center, it looks like, is at 1, 2, and since it doesn't go up at all, that's going to be 2, 0. And that's always given at hk. So my k value is 0. Hold up, if it's 0, do I have to write y minus 0? I don't think so. I think I can just leave that as a regular old y as long as I remember to square it. Oops, here we go. Now I am still going to have to put that over the major axis. So the major, again, is going to be the longer one, and it's clear to see what that's going to be this time. It's the vertical, so count from the center to the vertex. 1, 2, 3, 4, 5, 6, 7. And because of the formula over here, it says I should square that 7, so it is 49. And then I'm going to add parentheses, x minus h. H is 2. Then I'm going to square it and put it over. How far left and right does this go? From center to covertex, it is 1. So 1 squared is 1. And it always equals 1. Okay, so that's all that you're going to do today. Here's a view of that again. And I'll see you tomorrow for our last conic section.